In this question, you have two spheres, P and Q. Both are made of copper and they are at rest on a frictionless surface. So they are exerted with the same force F and with the same timing. So obviously both P and Q, they will accelerate. And the volume of Q is less than the volume of P. That means to say if this is P, the volume here is bigger, this is Q, is smaller, and both are exerted with the same force. Now this question is actually very direct. You should know that we have learned density. Remember in the class we say that density of a small piece of gold and a big piece of gold, or you cut the gold into small pieces or whatever, the density remains the same because it's unique to the material, it's made of the same material, so density remains the same. So for this case, since both P and Q is made of copper, the only thing that the quantity that will stay the same will be density. Straight away, that will be your answer A. Now the one that students get a bit confused is kinetic energy. So we'll go to that later on. So let's talk about mass and weight. It's very simple. If the volume is bigger and both are made of copper molecules, so the copper, there will be more copper particles here, so the mass of P will naturally be higher, and the weight, since W equals to mg, the weight of P will naturally be higher. So all these are very straightforward. So mass and weight will be higher for P. So now let's go to kinetic energy, which some students are not able to convince themselves. So I will go through a general method to actually prove to you, because Ke, everyone knows that the formula is half mv squared. Let's assume P, the mass of P is greater, but you also understand that due to its bigger mass, bigger inertia, the acceleration will be smaller. So the speed at that time, a specific time, will be lower. So one increase, the other one decreases. So it's like you can't convince yourself whether the Ke will be higher or lower, or will it even stay the same. So how do you prove it? Now let's start with the basic F equals to ma. Since the only force acting on both P and Q is F, so and both are the same, so the acceleration of the sphere will be F over m. It depends on the m. So, and the next thing is I apply acceleration equals to v minus u over t. The acceleration is F over m. The final speed is what I want to find at the end of the time t, and the initial speed is 0 because both start from rest and in a given time t. So the final speed of the sphere all depends on Ft over m. And as you know, the force is constant, the time is the same for both of them. So I can also say that the velocity, the speed of the sphere, is inversely proportional to your mass. So if we apply the Ke equals to half mv squared, so half is a constant, so your Ke is directly proportional to your mass, and I replace this speed with 1 over m square. So if I work it out, it will be m 1 over m square, and if I simplify it further, that will be your 1 over m. Your Ke is directly proportional, inversely proportional to your mass. So since your P has higher mass, the Ke of P will be lower than the Ke of Q. So you know that there will be a difference, it will not stay constant. So this will, hopefully this will help to convince you about the Ke. Alright, thank you.